So if you're anything like me, you'll have a load of passwords and files that you want to keep safe, but the only place you can store them is on your computer, which is connected to the internet, which is not really that safe. So in today's video, we're going to be building one of these. So it might just look like a normal light bulb, but actually inside, we're going to have a little secret ESP32 that's acting as an access point and an FTP file server. So you can keep your secrets, passwords and your files stored on an SD card connected to this ESP32, and only you'll know that network's there. So whenever you need those files, you can just log on using your phone or your computer, download what you need, and nobody will even know the server's there. So let's make a start. The first thing to do is to connect the SD card to the ESP32. So you can buy a little adapter to do that, or you can just use basically one of these micro SD adapters that come with micro SD cards. So here's the micro SD card. It's absolutely tiny. There's no way I could, but I don't really want to be soldering to those tiny terminals. But what I can do is I can simply plug it in to the adapter and then solder onto those rather large terminals. And this circuit diagram shows you exactly how to do that. So there's 7 wires you need to connect up. So just be sure to connect to the 3.3 volt output from the ESP32, not the 5 volts, or she'll destroy your SD card. But everything else is really straightforward. You just solder directly to this and then plug the wires in as shown on this diagram, and it's done. It's as simple as that. Of course, we somehow need to power this ESP32, and to do that, I've chosen one of these high-link modules. So these are pretty awesome. They're fully isolated AC to DC converters. So basically, they're taking AC in up to 260 volts, as you can see on the slide, and they give an output. In this particular module case, I have the 5 volt module, and it gives a 1 amp output, which is more than sufficient for ESP32 using Wi-Fi. Just looking at the input parameters, they're expecting around 240 volts AC for the UK, but they'll go right down to 120 volts for US. You can see they draw very little current, so 200 milliamps on the input side. And yeah, the mean time between failures, is 100,000 hours, so plenty time. For the particular module I have, I got the 5 volts one, obviously. It can give a maximum output current of 1.2 amps, but its long-term output max is really 1 amp. It's really tightly regulated, 0.2%, moderately efficient. It's not the most efficient, look at that. So at 230 volts, you're expecting around 70% efficiency, which isn't bad. But anyway, as you can see, I'm soldering it up. I've soldered it to the ESP32, and I've basically wrapped it in tape. It looks a bit messy, but I was kind of worried because the inside of the bulb is metal to help heat dissipation from the LEDs. And of course, I don't really want my mains electricity to short to a metal housing when I have it up in the ceiling. So obviously I'm wrapping it in tape. It's definitely not the best way. There's probably much safer ways of doing it. So really, if we want to put the ESP32 inside a light bulb, we have to open that light bulb, which is a lot easier to say than it is to do. So you can see here I'm prizing it with a screwdriver. It's actually, if you can get a small thin bladed screwdriver in and just sort of pop the seal, it breaks the glue, and then you can basically pull it apart with your hands. And inside you see like a little aluminium PCB, which has got 8 lights sort of distributed around the circumference. It's got a bridge rectifier and a sort of an LED controlling IC. On the back of it, there's an electrolytic capacitor and basically 2 wires that go down to these 2 terminals at the bottom. These terminals are pretty rubbish. There doesn't seem to be any proper sort of physical connection other than sort of a compression between the wire and the actual terminal. So I don't really know what's going on there. Maybe they're wrapped around or something, but I don't really see how that's constructed. But anyway, once we've dismantled the bulb, we can actually put the ESP32 in there with its power supply. The next task is to install the ESP32 and the AC to DC power supply inside the bulb housing. And the trick here is to make sure it doesn't short out. The first thing to do is really to connect the terminals at the bottom of the lamp, and this is really difficult. So they can't be soldered to, they don't take solder. They don't really have a screw or anything. There's nothing really to do other than to wrap wires around them and hope they stay in place, which I don't really like, but I don't see any other way of doing it. So yeah, as you can see, I'm basically wrapping the wire around the terminal and then shoving it into the hole. Far from ideal, but it is what it is. It seems to work and it seems to be relatively strong. So the next step is really to put the ESP into the housing and just make sure there's no terminals, I/O on the ESP or the sort of 5-volt outputs, or even the worse, the AC inputs are actually touching that metal housing with inside the bulb. I basically covered the ESP32 in tape to prevent that from happening. It's not a permanent long-term solution. I would like a better solution than that. But for now, it seems okay and it seems to work. And it seems like it'll stop the connections touching the metal housing, which is, after all, what we really need. So once I'm pretty confident that that's all set up correctly, and to connect the ESP to the computer and get the code uploaded. So let's go and have a look at that. So now I know my ESP32 works, I'm going to put my code on it to actually create an FTP server and create an access point. So the whole point of this is it's going to be hidden away somewhere. And when I turn it on, I get the access point that I can connect to with my phone or my computer and access all my passwords and all my files stored on the SD card. That's what this particular code does. So there's, including 2 libraries, the standard Wi-Fi library and this ESP32 server library. So I've actually modified this library, and I'm going to put full details about what you need to change on my blog so you can download them if you want to try this. Basically, the ESP creates an access point with an SSID of my ESP AP, simple password. I can connect to that with my phone or my computer, and then I can access the files on the SD card. So as you can see, there's not much code here. The big challenge was actually modifying the library to be able to create an access point. So if you download the library from the library manager, for example, or GitHub, then it doesn't allow the ESP to be an access point, just a client on your own Wi-Fi network. That's no good. I don't want all my secret files appearing on my home network where anyone can connect, like my friends and things like that. So let's upload this, see what happens. So here you can see we've started our access points. We've got our host IP, our gateway IP, 192.168.4.1. SD card's opened, and it's waiting for an FTP connection on port 21. So let's open an FTP client now and let's connect. So I've opened that. One thing I need to do though is I'm currently connected to my home network, so that's not going to work. I need to be connected to my ESP32, so let's do that now. So it's connected, but it's looking for the internet. Obviously, there is no internet on this ESP, so that's not going to work. Let's go to the client now and let's make a new connection. I already tried this, so there's my IP of my ESP32. And click on that, click login. You can see down here on the serial terminal that it says a user ESP32 connected, and the password was ESP32. So there I'm in. I'm basically on my SD card now. So if I go on my computer, let's go into our secret files folder. You can see here I've got some, basically text files that are secrets. We can just drag these over now. Done. Those are now on that SD card, which is going to be on my little device hidden in my light bulb. So whenever I need to connect and get those passwords, because I can't remember them because they're really tough, I can just connect to this secret network and download the files. So if you think about it, it's moderately secure. At the minute, it's not great because the SSID is being advertised or broadcast. So I have another file that basically hides the SSID. So I'll put that on my blog as well. So you need a couple of passwords, right? You still need a password to access the Wi-Fi created by the ESP32. So there's a password there you need to remember. Then you need a password to access the FTP server. And all right, these are really simple ones at the moment. But once you've done that, then you can have all your files stored there. You can put small files on. It's like a 32 gigabyte or maybe even 64 gigabyte SD card. So you've got loads of storage. It's pretty slow, I have to admit. If you drag like a video, I don't know, say 100 megabyte video, it's going to take a couple of minutes to download or upload, should I say. So it's not the fastest storage, but it is pretty secure. So now we've tested it, I've got my secret files on there. Now it's time for the proper test, right? We're going to stop using the USB. We're going to get it up on that light up there in my ceiling and see if it works. Let's give it a try. So I'm going to put the light bulb in that light. I'm going to see what happens. First I need to turn it off. I don't want to blow myself sky high. course, this is not very safe because I don't have a ladder. Ooh, it's a turning chair. I'm gonna go turn on the light now. If it goes with a bang, you'll be the first to know. So actually, I can see the bulbs lit up red because the light on the ESP32 is red. That's kind of a giveaway, but we can certainly fix that in a future iteration. But most importantly, do we actually see the ESP32 access point now? Let's give that a try. So okay, the light's on, but I'm not 100% sure if it's working yet. Let me just check my Wi-Fi connection. So I'm connected to my home Wi-Fi at the moment. Let's change that. I can see the access point. Connect. Okay, let's open a new connection for an FTP connection. Okay, that's the right IP address. Log in. It's asking for a password, which is a good sign. Boom, we're in. I can see my secret information. So basically, my Wi-Fi server's in that light bulb up there. It's got my files that I uploaded earlier from my computer, and I can access them via the FTP. I could probably use my phone to do that or anything, so I'm really pretty impressed at that. It would be even better if the light, as in the lamp, you can actually see the light from that, so you could still use it as a functional light bulb, because it's a little bit suspicious, obviously, when you come into a room. The light doesn't come on with a switch, but the bulb is emitting a red glow, so that's kind of a bit of an issue, but it's something that's easy to fix. Pretty much, I had to use the big ESP32 rather than a small one because my small ESP32-C3s, I've got a really crappy Wi-Fi, so not very good as Wi-Fi servers, and I've ordered some new ones, but they haven't arrived yet, so I had to use the big dev kit board, and obviously that's a little bit big and it takes a lot more space up in the bulb. If I used the smaller one, my plan was to actually include the light as well, because that would be really cool. But that's something to look at in the future. I think basically the concept's proven. You can have a secret Wi-Fi server, and I've also got a file that stops the SSID being broadcast, so nobody would know it was there on your network. So I've uploaded that on my blog, so you can check that out if you like. And that's really the end of my video. So if you enjoyed it, please like and subscribe, leave a comment, let me know your thoughts. Try building it, see how you find it. See you in the next one. Oh, by the way, I'm not so stupid to put Bitcoin seed phrase online. So if you did try it and it opened somebody's wallet, then it's not my wallet, I don't have one. And if it made you a millionaire, then well, good luck to you. So see you in the next video.